In this video, we are going to go over how to code a script to find the derivative using the central difference method without using a for loop. So first we'll go through the method using a for loop, and then we'll vectorize it, which is a method used to not use a for loop. So central difference, we can't calculate the central difference at the first point or at the last point of our data. So I like to go ahead and plug in either not a number, or I could use forward difference to calculate it at my first value and backward difference to calculate it at my last value. So I can do either of those methods. So I'll go ahead and say that dy dx of 1 is equal to not a number, or I could use forward difference here if I was concerned with losing information right there. And I'm going to say dy dx of the length of x, so that last point is also going to be not a number. Or I could use backward difference here. Next, I'm going to have a for loop that says for I equals, I'm going to start at the second point and go to the second to last point. So one way that I can do that is I could write the length of x minus 1. And in here, I'm going to calculate the dy dx of I is equal to the y value before, so I minus 1, minus the y value after, I plus 1. And that's going to be divided by 2 times h, or to account for maybe a changing h or changing dx, a changing step size, I could say x before, x I minus 1 minus x I plus 1. So if I go ahead and run that function, I should get a dy dx of all my values here. So I have a negative slope, and then it goes to a zero slope, then positive slope after that. If we had a lot of data, this would be a somewhat inefficient method to calculate our derivative because the for loop can take a lot of time. So this is where we're gonna vectorize. So we're going to write the above calculation without using a for loop. So once again, we're going to have these two lines. I'm going to change the name of this. Let's call it dy dx1 and dy dx1. And then I'm going to calculate dy dx1. And I want to calculate dy dx1 all the way from 2 to the second to last value. So one way I could say the second to last value is the length of x minus 1 value. But because I have this here and I've already specified the length of dy dx1, so I already know it's the correct length, I can do the second to last index by saying end minus 1. And on the top of this equation, we have y. And if 2 to end minus 1 is I, then we're going to do I minus 1, we're going to subtract 1 from 2, so it's going to be y1, and we're going to subtract 1 from end minus 1, so that's going to be n minus 2. Next, we have a minus, we have y, and here we have I plus 1. So I was 2 to end minus 1, so we're going to add 1 to both of these. So we're going to go from 3 to end. We're going to do the same thing, but this time, because this is a vector, we need to use our dot divide. We're going to have x1 to end minus 2 minus x3 to end. So if we run that, we see that we get the same answer that we got before. And this is going to be a little bit more efficient, especially if we have a lot of data. So this is how we do our central difference without using a for loop. If you feel uncomfortable about using these ends, because that's special for MATLAB language, we could instead say n is equal to the length of x, that was a capital X, and then we can comment out that line. We can retype this and replace each of these n's with the letter n. So there we've done that, and we still end up with that same answer there. So I hope that was helpful, helping you write your central difference without a for loop. You can do the same thing for your forward difference and your backward difference as well.